Hello, good evening. Welcome to the third session of Parabola. Yes, in this session, we'll discuss some more questions related to the equation of parabola and focus directrix property. And then we'll continue to the general equation and then further properties. So have a look. Already you have seen similar kind of problems in session 2. So you can pause the video and try solving them. Okay, they are the previous year questions, okay, of similar types. So vertex of the parabola is given to be 2 comma minus 1 and its directrix is given to be this. So I have the directrix here, which is 4x minus 3y is equals to 21, and the vertex of the parabola is given. So here it might be the vertex. Vertex is given here to be 2 comma minus 1, and we want the length of lattice rectum. So for finding the length of lattice rectum, again we will use the information. What is the information? Suppose I have a parabola here, and this is my focus. So whatever is this length, the same length is here also. And this length is basically A. So this length is also A. And the length of lattice rectum of the parabola is what? Length of the lattice rectum is nothing but 4 times A. So length of lattice rectum is 4 times A. That means if I can just find out this distance and multiply this by 4, then I get my length of lattice rectum. So all it is required is simply to find the distance of this point from this line. So that is distance of the vertex from the directrix is 1/4 of the lattice rectum basically. So if I whatever distance I get here, okay. So say this is my distance A from here to here, then length of lattice rectum is 4A. So let's find out the distance V to this I'll call it point say M. So Vm is equal to A. Then length of lattice rectum is going to be 4A. So let's find out Vm. Vm is basically the perpendicular distance of this point from this line. So we can plug in here 4 into 2 minus 3 into minus 1 and then minus 21 over 4 square plus 3 square, which is 16 plus 9, 25. Square root is going to be 5. So we get this EVM. And this turns out to be what? 4 into 2, 8 plus 3, 11 minus 21 over 5. This turns out to be 11 minus 21 is 10. 10 over 5 turns out to be 2. So I know my distance Vm from V to M is nothing but 2. So therefore, length of lattice rectum is going to be simply 4 into 2, which is 8. So the answer would be 8 for this question. Moving to the next one. Yeah, so this equation also seems to be of a similar type, and it's quite familiar. So the equation of parabola whose vertex is at 5, 4, and the directrix is given to be this. That means it's exactly the same, and we need this point. We need, in fact, the equation of the parabola only. So suppose this is my parabola. Here I have my point 5, 4, and the directrix is given to be 3x plus y minus 29 is equal to 0. What I'm finding is I'm finding the equation of parabola. So when I have the directrix, my intention should be to find out the focus, because if once I get the focus, my entire goal would be now to just use the focus directrix property. So how can we get the focus? This vertex we have is 5, 4. So what we will be doing, we can find the foot of perpendicular from of this point to this. So say this is my vertex, this is a foot of perpendicular, and this is S. So find foot of perpendicular. So find foot of perpendicular of V. Find foot of perpendicular of V in the directrix. So find the foot of perpendicular V in the directrix. Say it is F. Once you got the foot of perpendicular, we can get S by midpoint formula. By midpoint formula, because I know that vertex is the midpoint. So by midpoint formula, we can get S. Why? Because we have F plus S is equal to 2V. We can use this fact and then apply focus directrix property. So apply focus directrix property. So apply focus directrix property, that is, now we have again the same thing. So SP, and here I'll be calling it M. So you have SP is equal to what? PM. So after solving this thing, you get a similar equation of parabola and just compare with the given equation. Get the equation of parabola and compare with the given equation. So I'm leaving this question for all of you to try and then get the answer. Okay, I'll be telling you the answer by looking at the side given here, and this answer turns out to be, yeah, minus 576. So correct answer is minus 576. Please verify it. Okay, it is an exercise for you all because already we have solved numerous problems based on this. Okay, we have one more. So you can polish your hand at this problem, and then we'll move to the next sessions. So if the length of lattice rectum of parabola whose focus is at a comma a, and the tangent at its vertex is x plus y is equal to a, then is 16 given. So the length of lattice rectum is given to be what? 16. And then there is some parabola here, and this tangent at the vertex equation is x plus y is equal to a given. Tangent at its vertex is x plus y equal to a, and its focus is what? A comma a. So this point is a comma a. So a comma a is given, then we need basically length of lattice rectum. So just think over a bit. We know that length of lattice rectum is 4a basically. Length of lattice rectum is 4a. Total is 4a. Now I just want, this is 4a given. 4a is given to be 4a, you can think of given to be 16. That means from here I get a is equal to 4, but that's not the correct thing because this is 4a. 4 is our notation. This a is different. So do not compare here directly. Otherwise, this would give a wrong result. So we just know length of lattice rectum is 16. So this much we should know that length of lattice rectum is 16. And this distance, whatever is there, it is basically what? 1/4 of. Because in our standard parabola, we have this is my focus, a comma 0. So this was a. So if this is a, then from vertex to focus, Vs is basically what? 1/4 of length of lattice rectum. So this we should know. Vs is 1/4 of length of lattice rectum. So now I'll be using this thing. So Vs means what? Distance of this is S, this is V. That means I need to find out Vs. Vs is basically what? Distance of this point from this line. Okay, distance of this point from this line. So I'll be finding the distance this time, not foot of perpendicular. So please find the distance. That means this turns out to be what? A plus a minus a by square root of 2. This is my perpendicular distance of a comma a from this line. This turns out to be what? A over square root of 2. Now I know that Vs is what? 1/4 of length of lattice rectum is equal to what? A over root 2. Now this turns out to be what? Length of lattice rectum is 16. So 16 over 4 is equal to magnitude of A over root 2. So from here I get magnitude of A is equal to this is 4 root 2. So this gives me 4 root 2. Now let's see the general form. So see now here, if you notice, then all these equations we are getting the length of tangent at the vertex, or you say the directrix, they are not standard like x is equal to a or y is equals to b. That means now my parabola is what? Rotated. Okay. So whatever parabola we have seen, suppose this was my original parabola, y square is equal to 4ax. Now this is being transformed to some other point. I mean, this is being transferred to some other point. So I'll be having an equation like this. So this turns out to be y minus k square is equal to 4 times x minus h. And now what we are doing is the axes are also rotated. That means I now have a parabola this way. I now have a parabola this way. So this is what? Original. This is what? Shifted by keeping the axis parallel. So keeping the axis parallel. Keeping the axis parallel. And this one is what? Rotated. So rotated parabola will be general equation of parabola. So here we need to go for the general equation of conic. So recall the general equation. What we have written is focus directrix property is, suppose I have a line. I'm sorry, I have a fixed point, which was S alpha comma beta. And then I had a fixed line, which turns out to be Lx plus my plus n is equal to 0. And then I found the equation of, locus of this point ph comma k. So we have said that SP is equal to PM for the parabola. SP is equal to PM for the parabola, or else if I recall the general equation, then I'll be considering SP is equal to E times PM. So SP is what basically? It's the square root of H minus alpha square plus K minus beta square is equal to E times PM is LH plus MK plus N over square root of L square plus M square. This turns out to be the general equation of conic. So general equation of conic, now we will put E is equal to 1 as per the definition of parabola here, because we want E to be 1. We'll put E is equal to 1 and simplify. I'm not simplifying this, that anyway beyond the scope of this session. And after simplifying, we get the general equation which looks like this. Say ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. This is the general equation of conic. Not only for parabola, but for everyone. And now here what we need to know is, for this general equation of conic, the determinant delta should not be 0. Okay? Because if delta is equal to 0, then this equation will represent a pair of lines. This represents a pair of lines, or many more conditions are to be inspected here. Okay, because to represent pair of lines, that's not the only condition delta equal to 0. Many other conditions are also need to be checked, which we will discuss in the straight line chapter. Represents pair of lines. But this is the general idea, that if determinant becomes 0, then this represents pair of lines. Now, what determinant I'm talking about is this. The determinant, when I say determinant turns out to be for this value, which is a. And in fact, if you cannot remember this matrix, then please be informed that you can remember it by some kind of funny stuff that all high school girls, having beautiful faces, going for cinema. And please don't forget that I have written entries like this only. So take A, H, G, H, B, F, G, F, C, and just paste it here. So this delta should not be 0 for the parabola, for the conic, in fact, not only parabola. So delta should not be 0. And second part is that E should be equal to 1. And the third part is that H square minus AB should be equal to 0 for the parabola. I should have H square minus AB is equal to 0. Then this would represent a parabola. So that means we don't have to worry about anything that comes to our way. Most of the students I have seen, they would think that y square is equal to something. Only one side should be quadratic, one side should be line. That's not true, because parabola can be rotated. So in that case, we're going to have equations like this, which we already have found. In fact, if you remember that minus 576 question, this one, this was the general equation. In fact, we have obtained. Now let's see. There I have this equation. Now I want all possible values of lambda for which this equation represents a parabola. So of course, this is the general equation. That means I should be thinking about only two things, that my delta shouldn't be 0 and h square minus ab must be equal to 0. So there is no point of solving this guy for the time, because delta is not equal to 0 means how would I get lambda? So lambda will be given by the condition which is holding the equality. So we'll go for h square minus ab equal to 0. So if you have 9x square plus 4y square plus 2 lambda into xy plus 4x minus 2y plus 3 is equal to 0. So if you compare with ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. So we get a is equal to 9, b is equal to 4, h is equal to lambda, g is equal to 2, f is equal to -1, c equal to 3. So since we want h square minus ab is equal to 0, that means I'll be having lambda square minus a into b is 36, which is equal to 0. That means we'll be having lambda is equal to 6 or -6. Now, it can be easily verified. It can be easily verified that delta won't be 0 for these two values. Okay, so the possible values are 6 and -6, for which this equation will represent a parabola. I hope you're done with this part. Now moving to the next section. Okay, so we will now discuss here the position of a point with respect to a parabola. So position of a point with respect to a parabola. With respect to a parabola. So position of a point with respect to a parabola. That means what? Say if I have a parabola, so this one, then this portion is said to be the interior region. This is said to be the interior region of the parabola. Interior region of the parabola, interior of parabola, both are same. Grammar won't change the subject. So interior of parabola. And this region is the exterior of parabola. Exterior of parabola. And this line, this curve which you see is nothing but parabola. So now if I have a point here, say P. So this is my point P, and say I have a point Q, and I have a point R. So what are the positions? Okay. What are the positions of PQR? So what are the positions of PQ and R with respect to this parabola? With respect to this parabola. That means I want to find out. See, if some random person, if someone gives you randomly a point and a parabola and asks you whether this point is lying outside the parabola, inside the parabola, how do we get it? That is our goal. So let's go ahead. So now for this purpose, is the aim clear? Aim must be clear first because our goal is to get, our goal is to get P, Q, and R are there. Now whether they are lying outside, inside, that means they are lying outside or lying inside, or they are on the parabola. How do I get it? Or they are on the parabola. They are on the parabola. See, this position of the point is very important for studying tangency and the rest of the things. Okay, but mostly we'll be using for the tangency part. Okay, so let us see. Now imagine I have a parabola here. Okay, please utilize this idea. Say this is my parabola. Y square is equal to 4ax. And for conic say converse, we'll be writing it y square minus 4ax. Now onwards we'll be writing it s is equal to what? Y square minus 4ax. Now understand this thing. And suppose if I have a point, let P, if I'm saying x1, comma y1, P any point in the plane. P any point in the plane where this parabola is. Since we're talking about the parabola now, so of course this is my xy plane. Now P is any point. Okay, say my P is here outside. This is my point x1 comma y1. Now I want to find out the location of this point, whether it's P is outside or inside. So for developing the theory, we need, I'll just drop a perpendicular like this. We will just drop a perpendicular. So this point turns out to be what? x1 comma 0, and this point on the parabola is going to be x1 comma some y we don't know what it is. So clearly if you see this distance, y1 is definitely bigger. Y1 is definitely more than, say I'll call this point to be y2. Y1 is definitely more than y2, because this distance is y2 only. So y1, this distance from this point, I'll say point you take m. So MP is definitely more than this point, x1 comma y2. So we just have taken the perpendicular. So I just want to find out what is this y2 basically. So we'll write down, since x1 comma y2 lies on the parabola, lies on the parabola. This y1 is more than y2 is common sense. It's visible that yes, y1 is more than y2. So now I'm saying that x1 comma y2 is lying on the parabola. So this implies x1 comma y2 will satisfy this equation because it is on the parabola. So if it is on the parabola, it must satisfy the equation. So I'll be having y2 square is equal to 4a x1. y2 square is going to be what? 4a x1. Now what will happen? See, I have here y1 is more than y2. So that means in terms of distance, if I compare, because we do not know whether this is downward, upward. So it's better we square this. So y1 square will be more than y2 square. Now y2 square is what? So y1 square is more than y2 square is 4ax1. This is y1 square is more than 4ax1. That means I can now write down y1 square minus 4ax1 is positive. Y1 square minus 4ax1 is positive. That means this point S, we will now denote, we will now denote, we will now denote S1. S1 is nothing but what? Y1 square minus 4ax1. So this implies what? That S1 turns out to be what? Positive. So that means if I want to see any point is lying inside or outside, I just need to plug it into the parabola and see if S1 becomes positive. So if S1 is positive, this implies what? P lies outside the parabola. P lies outside the parabola, or to say it's in the exterior of parabola. And if S1 is negative, so if S1 will be negative, that means what will happen? You see, if P is lying inside, then this time your Y2 will be more than that point. So in this case, what will happen? S1 will be negative. So this implies P lies inside the parabola. P lies inside the parabola. P lies inside the parabola. And S1 is equal to 0. This implies P is on the parabola because it is satisfying the equation. So P is on the parabola. I hope this is quite clear. You can do the same thing with the other parabola also. X square is equal to 4by. Both will give the same result. So for the important point is what? That if S1 is positive, so here we will now write down S1 positive, P is outside, and S1 negative means P is inside, P is inside, and if S1 is equal to 0 means P is lying on the parabola. P is on the parabola. Is it okay? Now let's move ahead. Parametric points on the parabola, or is a parametric form of the parabola. Parametric form of the parabola. So parametric form of the parabola is very important. Now imagine. So I'll be writing here the parametric points, or it's a parametric equations, parametric form, or you say any point on the parabola. We always assume in the parametric form just for simplifying our calculations. It's very simple. Now for parametric form of parabola, what I'll do, we'll just write down all four parabolas here. Okay, so the first one is here. So I'll keep the diagram short. Second. Here I have four parabolas. Y square equal to 4ax, y square equal to minus 4ax, x square equal to 4by, and minus 4by. So I just want a point. That means what? If I want a general point on the parabola, okay, means I just need to work, or let's say I want to solve a particular problem. So I cannot work with just one particular point. So indeed, what I'm saying is I'm just considering a point on the parabola which will work in general. That means I can work with a parametric form. So for this, I'll be taking x is equal to at square, so that when I plug in here at square, this y becomes a perfect square. So in this case, I'll be getting y is equal to 2at. So this parametric forms will work for this parabola. And when I have minus here, so I'll be taking x is equal to minus at square, so that this minus and minus will compensate each other, and then I'll be having y is equal to 2at itself. You can work even with minus 280, that's not a problem. It's perfectly your choice. You have x square is equal to 4by. Now this time I'll be choosing y first. So y is equal to bt square. So x will become 2bt. You can even take minus, no problem. Don't choose y as minus, otherwise there will be a big problem. And in this case, again, I'll be choosing y is equal to minus bt square. So x will become 2bt. So these are the parametric points, or you say parametric form of the parabola for standard parabola. If my parabola is not standard, this is for the standard parabola. That means centered at vertex is at 0, 0. So if parabola is shifted, so if parabola is shifted, if parabola is shifted in the sense what? So if that is vertex is now some h comma k. So in this case, I'll be having x is equal to at square and y is equal to 280 I had earlier. So now what I'll be doing, I'll be dealing with plus h and plus k here. For the first one, and second one will become same, x is equal to, you'll be taking minus at square and then just go on adding plus h and plus k. This is what we have discussed in the earlier sessions also. This is for the second parabola. And then for the third one, I'll be having um, x is equal, y is equal to bt square plus k. This is y, not x. Bt square plus k. Y is equal to bt square plus k. And this is x is equal to what? Minus 2bt plus k. I guess this is plus. For the third one is this, no? Yeah, 2bt square plus h. So should I write an h? So this is for the third parabola, and similarly you can write down for the fourth parabola. Okay, so if my parabola is shifted, then we just have to add the shifts, nothing else. Okay, now moving further. And these parametric coordinates are not just unique. In fact, whatever comes to your mind, say you can work with the calculations, you can easily deal with. Like say, for example, if someone asks me, let's take y square is equal to 16x. Y square is equal to 16x. So the question is, can you give me a general point on this parabola? So can you give me a general point on the parabola? Can you give me a general point on this parabola? That means that point should carry the entire parabola. So if someone would ask me this thing, then I will say this is 16x. So I can take x is equal to 80 square. So 4a turns out to be what? 16. That means a is equal to what? 4. Now here onwards I'll be starting. So if you take here 4, so I'll be taking 4t square, comma, then this is 2a. So 8t. This is going to be at any point of this parabola. So whenever I have to solve a particular problem or I'm dealing with anything, I'll be just taking the general point on this parabola, or it's the parametric point on the parabola. This is special for tangent and normal related problems. Coming to the focal distance of a point, focal distance of a point. So I'm finding the focal distance of a point. That means what? Distance of a point from the focus. Distance of a point from the focus. We might feel that what's the problem here? Distance of a point from the focus. That means we can use the distance formula. Who would stop us? No one is going to stop you. Imagine I have a parabola here. So this is my y square is equal to 4ax. Distance of a point from the focus, and this point is on the parabola basically. And distance of a point on the parabola. Wait, please let me correct it. Distance of a point, because focal distance of a point written, right? Focal distance of a point on the parabola from the focus. So distance of a point on the parabola from the focus is what? This is my 0, 0. And here I have the directrix, which is x is equal to minus a. We have taken the standard parabola for the simplicity. Now let's say I have a point here, which is P. Of course, x1, y1 is on the parabola. So we'll write down here, let P x1, y1 be a point on the parabola. So let P x1, y1 be a point on the parabola. Y square is equal to 4ax. So I have a point here, P. Now I want distance of P from this focus. That means my goal is to get SP. So how can I get SP? Of course, we can use the distance formula, but then there is no point in studying the parabola, because if we have to study distance formula only, then there is no point. We'll see some beautiful things here. So imagine that SP is equal to PM, of course. Now this P length is what? From here to here, I know this is what? X1, and this is nothing but A. So since SP is equal to PM, so this is N now. SP is equal to PM total by the definition. So by the definition, I see that SP is equal to PM. So if my SP is equal to PM, then what I'll be having? PM is nothing but PN plus NN. So what is PN, by the way? It's going to be distance, which is X1 plus NN is going to be what? A. So SP is going to be simply X1 plus A. And now the point is to be taken care of is we are talking about X1. So in case if you're taking the other parabola, which is on the left side, so your X1 is distance, not the point. X1 is the distance basically. So this X1 and A both are taken to be positive. So distance of a point on the parabola. So SP is nothing but simply coordinate of the, abscissa of the focus, abscissa of focus plus abscissa of the given point. So abscissa of the given point. So it is as simple as that. Okay, that means SP is equal to simply X1 plus A. So suppose if I have the parametric form, so in parametric form, how can I write it? So in parametric form, I can write it. This X1, Y1 is going to be basically 80 square comma 280. So SP is going to be basically X1 is 80 square and then plus focus is A only. So SP is going to be A into 1 plus T square. This is going to be my focal distance of the point. So I just have to find a T. This is the focal distance of a point. The same thing is true even for other parabolas also. Okay, the idea should be same. Idea should be applied. Okay, this idea we can apply. Now, if in case if you're not interested here with this part, A comma 0, we know this length is y1. This length is y1. So you can even apply Pythagoras to get this distance, and you end up getting x1 plus a only. All right, we can use a. It depends upon you. Okay, how do you want? Since we are dealing with the basic definition, so SP is equal to PM, I find it a bit easier to use. Till this part, SP is equal to A into 1 plus T square is nothing but the focal distance of a point. Now, once we have got the focal distance, now we have a lot of properties related to the focal chord. So we will now discuss it one by one. Focal chord. So what is a focal chord basically? A chord passing through the focus. Chord passing through the focus of the parabola. It's called as the focal chord. Now let's see. So suppose if I have a parabola here, and this is the focus A comma 0. I have a chord which is passing through the now this is called as the focal chord. I'll say this is P, this is Q, and here I have S. So chord passing through the focus. Now our goal is to get PQ. So we want basically the length of the focal chord. I want the length of the focal chord. We're interested in knowing the length of the focal chord. Now let's see. To find this length of the focal chord, what I'll do, I'll prove one of the important result that if P coordinate is a t1 square comma 2a t1 and Q coordinate is say a t2 square comma 2a t2, then I'll be establishing the result that t1 into t2 is equal to -1. This is a very important result. What are we saying? That if we know the coordinates here at square comma 2at1, at2 square comma 2at2, then t1 into t2 is -1. That is, if one end of the focal chord is known, if one end of the focal chord is at square comma 2at, then the other end we can directly find out. Then the other end is a by t square comma minus 2a by t. We can use the fact that t1 into t2 is -1. So t2 is definitely going to be what? -1 over t1 square. So you can just simply replace here by this line. Now let us see what it is. So t1 into t2 is -1. So for this thing, we can just think over, okay, say PSQ, since PSQ are in the same line, or you could say collinear, but they are on focal chord. So that means slope of SP and slope of SQ both are going to be same. So therefore, slope of SP is same as slope of SQ. So let's equate the slopes. And of course, this T1 and T2 are distinct. Huh? T1 and T2 are distinct. So I'll be writing here T1 and T2 are distinct. These two are two distinct points. So slope of SP is going to be what? Y2 minus Y1, same idea we will apply. So 2AT1. So 2AT1 minus 0 over, what is this point by the way? It's AT1 square minus A. So AT1 square minus A will be equal to MSQ. So slope of this chord I'll find out, which is 2AT2. So 2AT2 minus 0 over AT2 square minus A. So AT2 square minus A. Now we can cancel 2A from here, 2A from here. We can take A common and finish it. So I'll be having T1 into, this is T2 square minus 1 is equal to T2 into T1 square minus 1. Now I can write down here T1 T2 square minus T1 is equal to T1 square T2 minus T2. We can transfer this one here. So I'll be having T1 into T2 common. and I'm left with T2 minus T1 is equal to, this will be T1 minus T2. So now from here, since T1 is not equal to T2, so I can cancel these two by taking one minus common. So I'll be getting T1 into T2 is equal to minus 1. So we now have cancelled the factor. This factor gets cancelled, leaving one minus outside. So we get T1 into T2 is equal to minus 1. Now we have proved this result that T1 into T2 is minus 1. So now we know Q. So what happens? Now we know Q. So if P is my point AT square comma 2AT is a point on the focal chord, is a point on the focal chord, then Q A over T square comma 2A over T with minus is the other end point, is the other end of the focal chord. So this is the other end of the focal chord. Now let's see what it is. So with this, we can get the distance. So now I have this parabola, and I am now finding this thing. So this is my P, this was S, this was Q. So I'm finding PQ. So therefore, instead of directly applying the distance formula, okay, we'll better go for SP. So SP is nothing but what? Focal. So we want basically PQ. PQ is nothing but PS plus SQ. Now PS is nothing but focal distance of P. Focal distance of P plus now Q I know, which is focal distance of Q. Which is focal distance of Q. And there is no need to memorize. You should know the concept, and this is very simple. So focal distance of P plus focal distance of Q. Focal distance of P is what? I know the point A. This is A comma 0. P is AT square comma 2AT, and Q also I know it is A by T square comma 2A by T negative. So focal distance of P is what we have seen earlier. It's just the abscissa we have to add. So I'll be having A plus AT square, and here I'll be having A plus A by T square. Now we can keep A common. So this will turn out to be T square plus 1 by T square plus 1 plus 1, 2, which is nothing but A into T plus 1 by T, the whole square. This is my PQ. So now we know the length of the focal chord. So length of the focal chord. Length of the focal chord is equal to A to T plus 1 by T, the whole square. This is my length of the focal chord. And now an important point. So length of the focal chord. Length of focal chord is basically what? A into, if you open this thing, so I have here T square plus 1 by T square plus 2. Now if I consider T square plus 1 by T square and apply A and GM inequality, so I'll be having T square into 1 over T square. So that means I get now T square plus 1 over T square is greater than or equal to 2. So that means length of focal chord in any parabola is greater than or equal to 2 plus 2 is 4A. That means minimum length is what? So minimum length of focal chord is 4A, which is nothing but the lattice rectum. So that means length of lattice rectum is the minimum length of the focal chord. So another very important property we have noticed. And now also one more important point, that PSQ, okay? So I'll be calling it the components of the focal chord. Okay, components of the focal chord. Property number 2. This is split into three, I guess. The first one is this. Second one is the length of the focal chord. Second one is the length of focal chord. This is point 2 and point number this is important point here only, and point number 3 is on the way now. The components of the focal chord. So components of the focal chord. So components of the focal chord are in HP. That is, have a look. So wait a moment, I shouldn't be writing this thing. First we will derive this, and then we will come to know what exactly I'm talking about. So this is true for all the conics, but we will study this for parabola, and then we will again see it in every ellipse and hyperbola as well. So this is my point P, which is 80 square comma 280, and this is a comma 0, and this one turns out to be a by t square comma minus 2a by t. So this point I have now, what I'm saying is that let us find out 1 over sp plus 1 over sq. So 1 over, what is sp by the way? Sp is length of the focal chord, which is a plus at square, plus 1 over, what is sq? Again, a plus a by t square. So now we can do one thing. We can take 1 over a completely common. So I now have 1 over 1 plus t square plus multiply this. So I'll be having t square over t square plus 1. So this eventually gets cancelled and we get only 1 by a. So 1 by sp plus 1 over sq is equal to 1 by a. But deep down, I know that we can write down 1 over sp plus 1 over sq is equal to, I can multiply here and divide by 2. So at least I get this thing to be what? 2a is nothing but semi-lattice rectum. Semi-lattice rectum. Semi-lattice rectum. That means I see that 1 over sp plus 1 over sq is equal to 2 by semi-lattice rectum. This is very important property. 2 by semi-lattice rectum. We're calling it semi-lattice rectum. That means now I see that semi-lattice rectum is the harmonic mean of components of focal chord. Okay, so we say that SP, SQ, and SL are in HP. Okay, this is also a very important property. So with these three, we'll now pack this session. We'll see you again in the next session. Bye bye.